How can we illustrate fractions? That is what we'll learn in this particular video. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. There has been requests from many subscribers and viewers to provide a video which could help explain fractions to children. So the request is from parents and teachers, and therefore this video is for the parents of small children who want to understand these concepts, and for junior and primary school teachers. I hope it will be easier with this model to explain the concepts. Feel free to write your comments and share your views so that we can improve on our delivery of requirements. So as we have mentioned here, we'll talk about a rectangle model for fractions. So I've shown here some rectangles and it's very easy to see how the model works, correct? So this ladder type of rectangle shown here, 3 parts have been shaded out of 5, which definitely represents a fraction, 3 over 5. And then we have this rectangle where 5 have been represented out of 6, so that is 5 over 6. And the third one, of course, is 1/3. So I hope that is very simple, correct? Encouraged to go through this video and understand how we could answer many questions which we have shared here. Well, take every question as a worksheet question. So now, I think you have understood the concept. Well, still, in case you want my guidance, you can always send an email on the address given. Now, we're talking about rectangle model. That is very clear as shown here, right? And of course, they represent fractions. You can see very clearly how. Then we'll in depth see how do we illustrate proper fractions, improper fractions, and then work with them with the help of worksheet 30 questions. Now, I have not numbered these questions, but they are almost 30. Now, to begin with, we have 3 over 5 as a fraction, 2 over 3 as another fraction, and 11 over 4. Let's try to understand these fractions first. Now, the very first one, we see that the numerator is smaller than the denominator, and therefore we call this as a proper fraction. The second one, we have a whole number with the fraction part. So this is called mixed number. The third one is an improper fraction since the numerator is higher than the denominator, right? So that becomes the improper fraction. We'll also see how do we convert between the mixed numbers and the improper fractions.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Right, so that's also very interesting. So let's begin with our model to illustrate the fractions. So we call this as a rectangle model for fractions. Illustrations really help to grasp the concept very easily. So 3 out of 5 means you take a piece which is a big rectangle here and it is divided into 5 equal parts. So 5 means this portion. So that is 5 equal parts. It is very important that all the parts should be treated as equal. If they are not equal, we cannot write this as a fraction 3 over 5. And 3, the numerator, represents how many do we select, right? So this is selected. So out of 5, how many did we select? That's the whole thing, right? So let's shade them. So we are selecting only 3 of them. So I'm going to shade 3 of them. You get an idea. So this becomes 3 out of 5. Perfect. So simple, right? Next one is the mixed number. 2 full, right? So this 2 is 2 whole. So as you have seen, we have 3 parts here, right? But 2 over 3 is the fraction part. So 3 here means divide equally. So whatever you have, in this case, we have a rectangle. We'll divide it in equal 3 parts. Now we'll select 2 out of 3. Now it says 2 whole and then 2 out of 3. You understand? So first, let me select this part, 2. So that means these 1/3, I'm selecting whole 2 of them. You get the idea. So that is 2 whole. And now, from the last part, I'm going to select 2. So that becomes 2/3 and 2 whole. You get an idea. From here, interesting thing which you will see is, these are all 1/3. Do you see this is 1/3, this is 1/3, this is also 1/3. But we selected all 3 of them. So how many 1/3 did we select? 1, 2, 3, 4, 5, 6, 7, 8. So we selected 8/3. Do you see that? So 2 over 3 is same as improper fraction 8 over 3. Correct? Many of us, especially the teachers and the parents, can easily write this as 8 over 3 by multiplying 2 by 3 and then adding 2, right? So you will normally do 2 times 3, which gives you 6, and then add 2 over 3, correct? So that is how you could actually treat this mixed number as. Gives you 8 over 3. However, a grade 2 or a grade 3 child can actually appreciate this part, that every unit, a rectangle in our case, we're talking about what? Rectangle model. Let's keep that focus, right? So we'll just make a rectangle, divide it into 3 equal parts since the denominator is 3. And then we select 1/3. So 2 whole and then 2 out of the third one. I hope you get the idea, right? So that's a very critical part of this video. If this concept is clear to you, then actually you can understand all other questions very easily. Now let's take up improper fraction. So this time we have 11 over 4. Definitely this is improper fraction where the numerator is higher than the denominator. Now how do I begin solving this kind of equation? We are trying to get 1/4. So what we do here is, we take a rectangle, right? We take a rectangle and then divide it into 4 equal parts. We want 11/4, right? This means we want 11 1/4. That is what we say when we say 11 over 4. So let's count. 1 by 4, 1 by 4, each is 1 by 4. Do you see that? So we have many of these, let us say, right? And we got 4 of them now. 5, 6, 7, 8, 9, 10, and now 11. So we have shaded 11 fourths. You get the idea. So that becomes 11 by 4. Do you see how I did it? I did not divide this by 4. I did not convert it to a mixed number. That is how a grade 2 or grade 3 student will do. So that is how we have to teach them. You get the idea. Of course, for you, you could always say, well, divide 11 by 4, and then you could write this as 2 wholes, which is 8 and 3 left, right? You can see that we have 2 wholes, right? So we have 1 whole here, the other one, and then we selected 3 out of 4. Make sense? That is the meaning, and that is how this particular model helps us to illustrate very easily improper fractions. So I hope with this the concept is absolutely clear. You may write your suggestions and comments, that is going to help me, or also contact me on the email address. Let's move forward. Now what we have done here is we have 3 practice questions for you. I would like you to pause the video and use rectangle model for the fractions given. How are we going to do it? 4 out of 7 really means what? It means that I'm going to create a rectangle divided into 7 equal parts. So what I do here is that I really don't know how long my rectangle will be. So I create like this. 1, right? 1 part, 2, 3, 4, 5, 6, and this 7, right? So assume all are of same size, exactly same. Now we need to shade 4 of them. So 1, 2, 3, 4, we'll shade them. You get the idea. So that is how I could create 4 over 7 fraction with the help of rectangle model. Perfect. Now let's look into the second one, where we have 1/3 and 1 whole. So that means my rectangle should be divided into 3 equal parts. So let me take one rectangle, right? I will divide this into 3 equal parts, correct? Okay, so that becomes 3 equal parts. So, but I have 1 whole here. So to represent 1 whole, I'll consume the whole rectangle. The second one, I'll again make exactly same rectangle and divide this into 3 equal parts. Now, how much should I shade? Well, because of that 1, I'll shade whole and then 1 out of 3. Make sense? That is how we are going to show it. Let's take the last one, which is 7 over 5. Now for 7 over 5, we need to divide a rectangle into 5 equal parts, right? So let's say 1, 2, 3, 4, and 1, 5. Okay. So that becomes my rectangle into 5 equal parts. And I want to shade 7 out of them. But we have only 5. That means I have to make 1 more. You get the idea. Improper fraction is greater than 1. So now I'll make 1 more. 1, 2, 3, 4, 5. Correct? And now let's shade. So while shading, 7. So 1, 2, 3, 4, 5, 6, 7. Do you see that? So I have shaded 7 of them. So let me just put a highlight here. And that gives me 7/5. So basically, out of 10, we shaded 7. You get the idea. But we are not writing 7 out of 10, are we? No, we are not. There is one whole, and then we shade fifths. So do you see that? Definitely, this is not equal to, this is not equal to 7 over 10. This is very important part. It is not equal to 7 over 10. In fact, it is 14 over 10. You get the idea? It is 14 over 10. We could say how? If I divide it equally, you can count. Those are 15 shaded out of 10. You get the idea. So 7 over 5, which is an improper fraction, some students think because we shaded 7 and overall there are 10, so it could be 7 out of 10. That will be incorrect. 7 over 5 means we have one whole and then 2 out of 5. You get the idea. That is what 7 over 5 is, and it is definitely much bigger than 7 over 10. You get the idea. 7 over 10 is a proper fraction lesser than 1, and 7 over 5 is improper fraction greater than 1. They cannot be equal. So this is another very important question answered, right? So now I think I have shown you a couple of things which always help students to improve on their understanding. Let's now have some practice questions. So these are practice questions for the students. You may use that as a worksheet, right? So we will illustrate 3 over 5, 2 out of 3, 3 out of 4. So what I've done here is already divided the rectangles into the required number of parts. So 5 means there are 5 equal parts, correct? And we have to select just 3 of them. So that becomes the answer. So it's an exercise which I think all students will love. And there we go for 2 out of 3 and 3 out of 4. You also see that 3 out of 4 really means that 1 out of 4 is not selected. You get the idea. So the concept of not selected is also important and can be seen. So here is a note. While explaining the students, also explain the concept of not selected. Likewise, in this case, 1 out of 4, right? So not selected what? Not selected 1 out of 4, right? Not selected 1 out of 3, not selected 2 out of 5 from the whole. You get the idea. Okay, now here are a few test questions. You can share these with the students, 2 out of 5 and all. And this is kind of a test. Now in this case, what have we done is given very interesting cases. All are different kinds of numbers, right? One of them, which we didn't talk about, is 1. Now how do I shade 1? I have given you a rectangle which is actually divided into 3 equal parts. Shading 1 really means whole, everything, right? So that is 1, correct? Now in this case, this one is really 3 out of 3. So 3 out of 3 is everything, whole, right? 1. That is what it is. The rest too, I think, are simple. So that could be a test question for the students, where we have concept-based question and thinking question. So that becomes tips. Make sense? Now, the next example here is to compare the fractions. So what you need to do here basically is identify the greater number. Fractions are also numbers, right? So we have to identify which is greater, half or 3 by 4. How can we identify this? The next one is 3 by 4 and 5 by 8. So let me do the easier one for you, which is half and 3 by 4. Well, for half, what I can do is I can divide this rectangle into 2 equal parts and select one of them. So that is half, right? Correct. So this is half for me. For 3 by 4, I kind of do the same thing. First I divide into half. However, we need fourths, so we divide into another half. Do you see that? And what we do here is select 3 out of 4. So that means we select this much. And that is 3 by 4, correct? And clearly 3 by 4 is greater. So this symbol indicates greater. So identify means I'll circle 3 by 4 as the greater one. Makes sense? So if you take the same size of rectangles, so important thing here to note is what? Same size. Do you see that? And then you shade and compare. It becomes very simple, right? Just as we did. So therefore, what I did was, I have drawn rectangles of the same size. Does it help? So, if you really like and appreciate my videos, you can put the likes there and your comments. And in case you want to explore more and understand any other topic, you can always send me an email on the address given. Now here is a test question again, and then we're given this time 3 fractions, 3 numbers. You have to arrange them in ascending order. Ascending means increasing order, from lower to higher. So you can easily compare by dividing them and then shading. So clearly, for half, I will take a rectangle and divide it into 2 equal parts. You will notice that all the 3 rectangles are of exactly same size, and therefore we can directly compare, right? So 1/3, let me divide this into 3 equal parts, right? So 1, 2, and 3. And 1/4, we need to select 3. Divide first in equal parts, then shade and compare, right? So simple as that. Half, you can see. So here is the solution, correct? 2/3 means this much. And 3/4 means that much. So as you can see from the shading itself, that they are already arranged in increasing order. Makes sense? Right? Such a easy process. Perfect. Okay, so I'll leave this last one for you. In this case, you have to shade one of each and see the denominator changes. So clearly, which one is the greatest? Can you do this? Well, that could be an interesting exercise for any student. I would like you to pause this video here and let some student try it out in your presence. That would be great. Perfect. So I hope you enjoyed this video. Feel free to write your comments and suggestions and keep posting your requirements. In case you want to learn from me, you can always send an email on the address given or contact us at the website. Thanks for your time and all the best.